So this is the second nomenclature video, and this one I'm going to focus on taking a mixture of compounds and determining what nomenclature system we're going to use. And so what you can see here is I've got a chart set up and a series of examples. Again, you should have the polyatomic ion table and the periodic table as well to work on with this. So this is essentially a flow chart for nomenclature. And you start by asking yourself questions almost like it's a computer program. So is there a metal or a polyatomic ion present? Critical exception, H followed by a polyatomic ion. That's going to be an acid, and that kind of throws a little monkey wrench into the neat flow chart. All right, so is there a metal or polyatomic ion present? Well, if there is, and the answer to that is yes, then what you know now is that you have something that is ionic. If there is no ion present, or it's an H followed by a polyatomic ion, which is an acid, then we have something that is covalent. So I'm going to pause here, and what I'd like you to do is to look down at the bottom and see if you can identify all the ionic compounds below and all the covalent compounds below based upon that statement. Okay, let's go through them. NaCl has a metal, so therefore it's ionic. HF starts with an H, has two nonmetals, it's covalent. H followed by a polyatomic ion, a sulfate. This is going to be covalent. It's going to be an acid. Recognize acids as a very important, exceptional group of compounds. This has got copper. That's a metal. Done. Ionic. Magnesium. Metal. Done. Ionic. Those all get the yes. They all go on this side over here, the ionic ones. P2O4. Non-metal, covalent. Ammonium oxide. I just named it, I shouldn't have done that. But ammonium is a polyatomic ion. This is ionic. Ammonium tends to throw students because it's the only positively charged polyatomic ion you're usually going to encounter. Be aware of it. You see that in there? It's ionic. Silver, ionic. That's a metal. SO2, two nonmetals, covalent. H followed by some nonmetals. And again, just a bunch of nonmetals. You can view it that way. This is going to be covalent. Once you decide whether your compound is ionic or covalent, there's a couple of other questions you need to ask. So the first question you might ask for if it's ionic is, does the cation have more than one positive charge? And you can get that on your table. Now, in the AP, you're not going to have that table. You kind of need to know the ones in the middle section there are usually going to need Roman numerals. You should know the few exceptions like silver. All right. So, is it going to need a Roman numeral? If it has, the answer is yes. If the answer to that is no, then it does not need a Roman numeral. So we're going to pause it right now and try to figure out which of the ionic compounds need a Roman numeral, which ones do not. So the only one of these ionic compounds that needs a Roman numeral is the copper oxide. All the other ones don't. So just to make it real easy, this is just going to be called ammonium oxide. You're done with the naming. This is just going to be called sodium chloride. I'm not going to write that down. This one right here is just going to be called magnesium oxide. And this one, are there any other? Oh yeah, this is going to be called silver sulfite. And I think I got them all. Okay. And this one here is going to need a Roman numeral. Why? Because there's copper 1 and there's copper 2. Now, since the oxide is -2, we know that this is going to be called copper Roman numeral 2 oxide. Because this has to be +2 because all compounds are neutral. All right, we've taken care of the ionic side. Now we're going to take care of the covalent side. Again, I'm going to teach the acids nomenclature system on the next page. Okay, so the next question you ask yourself is, okay, if it's all nonmetals, right, or a nonmetal followed by a polyatomic ion, is there an H in the front? And if there is an H in the front, the answer to that is yes. Well, you've got yourself an acid. If there is not an H in the front, then no, you've got binary covalent. So I suggest you pause the tape and determine which ones are which. And I'm going to put them in a list by the time you get back. All right, I'm going to name the binary covalent on this page, and we're going to switch to the next page where I teach you how to name acids. Binary covalent are easy, so this is just going to be diphosphorus tetroxide. The prefix is tetra, but we don't like the two vowels in a row. If you do that, I'm not taking off points. I really could care less. And I don't think any other chemistry teacher would make a big deal of it. This here is going to be called sulfur dioxide. However, if you become a graduate student in chemistry and you're still calling it tetraoxide or monocarbon monoxide, you'll probably elicit some laughter. So you might as well learn it now. All right, when you're naming acids, you have what are called binary acids and oxyacids. The general formula process is this. If you see a hydro out front, that's critical. It's a binary acid. So if you're doing hydro, let's say sulfuric acid as your example, okay, you know it's got an S in there, right? The H is going to be in the front, right? Now, since the charge on an S is always -2 and the charge on the hydrogen is always +1, the formula for this thing is going to be H2S. It's going to be aqueous, though. Acids are not acids unless they're in water as a general rule. So that's hydrosulfuric acid, which I'm going to differentiate from sulfuric and sulfurous acid. They're not the same thing. So if you have like HF, right, the F is -1. That's why we only have one H with it. This is going to be called hydrofluoric acid. Now, why and when you take out the middle syllable is beyond me. It's just, maybe it sounds better. So, you don't call this hydrosulfic acid. You keep the UR, it just sounds better. That's the only reason why I can think of. Somebody decided something way back in the day and it just stuck. Right? So if you have HI, this would be hydroiodic acid. So that's binary acids. You always use the prefix. Binary doesn't mean two atoms, it means two elements. And hydrogen is obviously one of them, followed by a non-metal. Now, if there's a pi-atomic ion in there, the nomenclature system is different. I'm going to use the sulfur ones because they kind of confuse students. Now these ions, this is a sulfite, and this is a sulfate. You look up the charges on these guys. They're both 2-, which means both of them are going to have 2 hydrogens. You can always figure out the number of hydrogens by looking at the charge on the anion that's in the acid. So if you're going to do something with let's say a phosphate, which is a charge of -3, right, or let's say ClO4 with a charge of -, right, we're going to name all these. This is a phosphate, and this is a perchlorate. Okay, the general rule is adic itis, and there's no prefix. So watch how this works. I'm going to give you the formulas first. So we're going to make an acid. So this is going to be H2SO3. Notice how I match this charge with the number of hydrogens, right? This is going to be H2SO4. Because this is -3, this is going to be H3PO4. Again, making the compounds neutral. And for the perchlorate, it's going to be HClO4. And the naming system is very simple. It becomes us. So this becomes, now I don't know why they stick the extra syllable, but that's why I did the sulfites and the sulfates, because they're kind of annoying. And if you get the middle a little wrong, I'm not going to take off points. But you should know that this is going to be called sulfurous acid. And because it's us, and 8 becomes an ick, so this is going to be sulfuric acid. Since this is an 8, it's going to be an ick. So this is going to be phosphoric acid. Again, don't ask me why they put the or back in there. They just do. All right. And basically go back to the element name and then stick the ick or the 8, ick or the us on the end. And for this one, this is perchlorate. Now, right, so this is going to be called perchloric acid. So that's how you name acids, right? If it's binary, hydro followed by the element with an ick, right? So it's sulfuric acid, or hydrofluoric or hydroiodic, but take the hydro in there. If it's an oxy acid, no hydro, so don't write that. You will lose points. So if it's an 8 pi atomic ion, you change it to an ick. If it's an 8, it becomes an us. I hope this helps.